Today we're digging into a pretty wild story. It's about how Tesla basically performed a brain transplant on its self-driving cars. They threw out hundreds of thousands of lines of rigid code and swapped it for an AI that learns to drive pretty much the same way you and I did, just by watching. Okay, so to really get what's going on here, you've got to see the before and after. On one side, you have the old way, a huge, teetering mountain of about 300,000 lines of C++ code. I mean, every single one of those lines was a strict rule trying to guess what to do in a world that's, completely unpredictable. And on the other side, the new way. It's just a single, massive neural network. This wasn't just some software update. It was a complete rethink of the entire problem. So let's start with that broken system. See, the original full self-driving system was built like most traditional robotic software. It was all chopped up into pieces. You had one part for seeing, another part for thinking about what to do, and a third part for actually, doing it. And that approach, well, it turned out to be a really fragile way to build a car's brain. So why did this old way fail so badly? Well, it created this cascade of problems. First up, something called cumulative error propagation. Think of it like a game of telephone, right? The seeing part of the car makes a tiny mistake. Then the planning part gets that wrong info and makes the mistake even bigger. And by the time it gets to the acting part, the whole thing is a mess. Each piece was trying its best on its own, but they weren't working together. And that just made the system super brittle. I mean, how could you possibly write a rule for every single weird thing you might see on the road? You just can't. And this quote from Ashok Ellaswamy, Tesla's VP of AI, just hits the nail on the head. He says, deciding whether to drive through a pedal or briefly use the oncoming lane is straightforward for a human, but nearly impossible to hardcode. And that's it right there. Human intuition is so hard to capture in lines of code. We make these split-second judgment calls all the time, and trying to write an if-then statement for every single one of them, well, it's pretty much impossible. All right, so now we get to the revolution. Faced with this brick wall, Tesla did something pretty radical. They took those 300,000 lines of code and just threw them out. All of them. And in their place, they put a single end-to-end neural network. So the whole game changed. It wasn't about trying to program a car to drive anymore. It was about training a single, unified brain to learn how to drive, just like a human. So what does that actually mean? Well, with FSD version 12, the system takes the raw video from all 8 cameras. We're talking just the pixels, nothing else, and that's its only input. It looks at all that video at once and directly spits out the driving controls, steering, accelerating, braking. It's like a single, unified brain that goes from seeing to doing in one smooth step. And you know what? This new approach totally unlocked the ability to scale things up massively. Just look at the leap from version 12 to version 13. All of a sudden, they could use 5 times the computing power for training, feed it more than 4 times the data, and the model itself got 3 times bigger. You just couldn't do that with the old, clunky, piecemeal code. No way. So what did all that scaling get them? The result was a claimed 100-fold improvement in miles driven between critical interventions. 100 times. Think about that. That means the car could drive, on average, 100 times farther without a human needing to jump in and take over. Getting that kind of jump from one version to the next is, well, it's absolutely staggering. It really shows you how powerful this new end-to-end idea is. Okay, so you're probably wondering, how on earth do you get a 100x improvement like that? It's not just one magic trick. This whole revolution stands on 3 huge pillars: data, hardware, and simulation. And you really need all 3 working together to make this thing possible. First up, data. And the amount of data we're talking about is just insane. Every single day, the entire Tesla fleet generates what amounts to 500 years of driving experience. It's like a constant fire hose of information. But here's the real genius. It's not just about collecting all that data. The trick is finding the tiny, tiny fraction, the really interesting bits that actually teach the AI something new. And that's where this super clever thing called shadow mode comes in. Just think of it like this. The AI is running silently in the background of every Tesla, like a student driver who never touches the wheel. It's constantly deciding what it would do, and anytime its decision doesn't match what the human driver does, bam, it flags that moment. It's an absolutely brilliant way to automatically find the interesting edge cases where the AI needs to learn. So those moments that get flagged, they feed into this constantly running process they call the data engine loop. It's a cycle. First, it detects when the AI got something wrong. Then it searches the whole fleet for more examples just like it. Humans take a look to make sure the data is good, and then it all gets fed back in to retrain the AI. It's this incredible self-improving system that just gets smarter and smarter with every mile driven. Okay, pillar number 2 is hardware. And the numbers here are just mind-bending. The system has to process something like 2 billion pieces of information from all its cameras and sensors. 2 billion tokens. That's a ridiculous amount of data to crunch. But here's the real challenge. It has to turn all of that data into a driving decision in just 27 milliseconds. 27. I mean, that's literally faster than the blink of an eye. And it has to do it over and over again, perfectly, every single time. Because, when you're hurtling down the highway, there is absolutely no room for error. And there's just no way to get that kind of speed with a regular computer. That's why Tesla builds its own custom chips. Their Hardware 4 computer is an absolute beast, and it's designed for one purpose and one purpose only, to run this massive AI workload at insane speeds. It's so optimized that it takes the data straight from the camera sensors. We're talking raw photons here, just to cut out every last possible millisecond of delay. And that brings us to the third pillar, simulation. And this one is just common sense, right? You can't just wait for a really dangerous situation to happen in the real world to learn from it. You don't want the first time your car sees a tricky scenario to be, well, for real. So they built what they call a neural world simulator. It's basically an AI that creates these super realistic, completely fake driving worlds so they can test FSD against millions of bizarre and dangerous situations over and over again, completely safely. Okay, so this next part is really, really interesting because it gets into how the AI actually thinks about the road. It's a totally different way of seeing the world. So the old way of doing things was to try and name everything first. Okay, that's a car, that's a pedestrian, that's a traffic cone. But Tesla's new way flips that completely on its head. Instead of asking, what is it? It asks a much simpler, more important question. Where is it? Basically, it just focuses on whether the space around the car is empty or if there's something in it. And this is why that change is so brilliant. Let's say there's a ladder that fell off a truck and is lying in the middle of the road. The AI has probably never been specifically trained on what a ladder is. But it doesn't matter. It doesn't need to know what it is. It just needs to know that the space it was about to drive through is, well, not empty anymore. And that's all the information it needs to safely drive around it. It's a way more flexible approach for dealing with all the random stuff you find on the road. So you might be thinking, okay, that's cool for cars, but why does this matter to me? Well, it matters because this whole approach, this blueprint, isn't just about cars. It's about how we're going to build all kinds of powerful AI in the future. Just think about it for a second. That idea of using one big end-to-end model, that could totally change the recommendation systems that decide what you see online. Or what about that shadow mode for finding the best data? Imagine applying that to search engines to make them way, way smarter. And simulation at this scale, that could be a game changer for something like drug discovery, letting scientists test out new ideas in a virtual world first. So really, the key takeaway here is that there's no single magic bullet. Tesla's breakthrough comes from building this complete, integrated system where everything works together. The custom hardware allows for a bigger model, which gets fed better data thanks to smart curation, and the whole thing gets tougher and smarter through simulation. It's a powerful loop where every part makes the other parts better. And that really leaves us with a pretty big question, doesn't it? Tesla taught a car how to drive by having it watch millions of hours of humans driving. It learned a really complex, real-world skill just by observing. So, what will we teach AI to do next? What's the next big human skill that we can teach an AI just by letting it watch us?